So this is the PowerPoint presentation for Lab 1 in Biology 105. And today we're talking about anatomical directions and microscopy a little bit later in our time together. So first we need to figure out what is normal. And we have a reference point here called anatomic position, or AP. And what this means is that when you are analyzing or discussing body directions with somebody else, you want to imagine that your patient is standing in front of you, as this woman is on the slide, standing in front of you, flat feet, looking forward, arms down to the side, palms facing forward. So this is anatomic position, or AP. And anytime we're going to have you describe, well, how is this finger related to that bone? Or how is that organ connected to another organ? We're always going to have you imagine the patient or the person or your client in anatomic position. Even if you find your patient in a fetal position in bed, or you find them, after some trauma, you still want to imagine that they're standing in front of you in anatomic position when describing body parts and their relationship one to another. Okay. So anatomic position, look at it, just understand what it is, and be able to think about replicating it. Now there's also a series of directional terms. They all have opposite terms or correlates to them, and let's go through these. You need to become very familiar with these. One of the challenges I have as an instructor is every semester bringing my vocabulary back down to the beginning and then building it back up with you as we go through the course. And it's important that you really get these directional terms down, because if I'm saying to you that something is anterior or posterior to something else, and you're still thinking, okay, what is anterior again? Oh yeah, it's in front of. You have lost the rest of the description. So you really want to get these to be automatic in your brain, and the best way to do it is to practice them. So when you get home, make sure you invite and welcome your entire family into Biology 105. Because not only are you enrolled in this course, so too are your family members. And you're going to drive them just a little bit crazy, but that's good, as you practice with them and ask them to practice some of these things with you. So anterior and posterior. Anterior means in front of, or toward the front, and posterior toward the back. That simple. Now there's another set of terms that mean the same thing when dealing with humans, and that's ventral and dorsal. Ventral means toward the belly, toward the front, and dorsal means toward the back. Think the dorsal fin on a shark. Now those are the same for you and me. Now if I'm describing something as being anterior, I want you to keep posterior in the same sentence in your description. If you're using dorsal, then you can use ventral as the opposite. But don't mix and match the pairs. Right? So don't in half of your conversation say, oh, it's anterior, and the opposite of anterior is dorsal. No, kind of keep the pairs together.
Which one are we going to use? Like, which set would we use more in a hospital setting?
Both.
Both?
Yeah. Yeah, these are very common. Anterior, posterior, ventral, dorsal, you'll hear them both used. Now, when we get to four-legged animals, like the fetal pig, there we're going to see that these are not equivalent. Okay? Because the anatomic position for a four-legged animal is on all fours, right? They're looking forward and their little tails wagging in the back. Now, for a fetal pig, ventral means toward the belly, toward the ground. Dorsal means toward the sky, right, toward the back. Anterior would mean toward the head, if you will, and posterior back toward the tail. So then we see in a four-legged animal that these are not equivalent terms. But this is a human anatomy course, and so these are, for us, pretty much equivalent terms. Superior, inferior, no problem here. We use these terms in other ways all the time. Superior, toward the top, toward the head. Lake Superior is the more northern of the lakes. It happens to be the biggest as well, but it's the more northern. Inferior, away from the head or toward the feet, downward. Okay? Again, you're thinking anatomic position. Caudal and cranial. These terms you'll hear more with four-legged animal friends, but caudal toward the tail, right? And cranial toward the head, toward the brain, toward the cranium. Medial and lateral. Medial, toward the middle of the specimen, toward the middle of the body. Think midline, think median in the road. Lateral, the opposite, toward the outside, in the periphery, on the outside edge. Deep and superficial. You hear enough CSI kind of shows to hear about a gunshot wound, right, that's deep or grazing the body, more superficial. So deep Deep down in the tissue, superficial, more toward the surface. Ipsilateral and contralateral. Ipsilateral means on the same side. Contralateral means on the opposite side. So if someone suffers a stroke and they have damage to their brain on the right side of the brain, they're going to see most of their symptoms on the left side of their body. That would be a contralateral relationship. We're crossing over to the other side of the body. Ipsilateral on the same side. So if I were to reach out with my right hand, burn my right hand on a stove, and pull my right hand back, it's all occurred on the same side of the body. That would be an ipsilateral kind of reflex or an ipsilateral response. Now, the two that give us the most trouble, I think, in the first semester or the first week of class are these two, proximal and distal. These terms are only going to be used to describe your arms and legs, your appendages, and proximal and distal. So we're talking about closer. Proximal means closer to the point of attachment. Your arm is attached at the shoulder to your trunk. Your legs are attached at the hip to the rest of your body. So let's think about elbow and wrist. My elbow is what to my wrist? My elbow is to my wrist. My elbow is closer to the point of attachment of the arm. So my elbow is proximal to the wrist. The wrist is distal to the elbow. Think distal, greater distance. So as I go down the arm, that's more distal. Okay? If it's closer to the shoulder, then it's more proximal. Same is true knee and ankle. The knee is more proximal, the ankle is more distal. You're only going to use distal and proximal on the appendages. If I was talking about my breastbone and my belly button, here I'm going to use inferior and superior. If I'm on my arm, I'm not going to use inferior and superior. I'm instead going to use proximal and distal. Okay, so just kind of get that. Those words are very special, only referring to the appendages. We can also break the entire body up into two very large regions, the axial and the appendicular. So what word kind of sounds like axial? The axis, right, the center of something, and appendicular, your appendages. So for this, you're looking at the skeleton, and the axial region would be the axis. That's going to be the skull, the vertebra, the rib cage, down to the sacrum. What's in the very center is axial. That'd be true of the skeleton or of your overall body. The arms and the legs are the appendages, so they're part of the appendicular region. So the question is, where's the border? Where's the dividing line? Well, the rule is this. The clavicle and the scapula, these two bones are holding the arm on to the body, so they too are part of the appendicular skeleton. So the appendicular skeleton are the entire arm and leg, plus the bones that attach the arm or leg to the trunk. So the clavicle, the scapula, and the pelvic bones. The pelvic bones, they hold the legs on, so they would also be part of the appendicular skeleton. Fair enough? So you'll see books dividing up the skeleton, see books dividing up the body into these two very large regions, axial and appendicular. Now this next slide, I know it's way too small for you to read on your PowerPoints. Right now I want you to turn to page 7 in your big Amerman lab manual. And it's a different picture, but it's essentially the same content. And on page 7, you're going to see a labeled body with all of these regions. Now, some books will call this regional anatomy. Some books will call this surface anatomy. These are basically the names for everything you can touch on the body. Some of these are very familiar to you. Some of these may be very unfamiliar to you. I suspect that some of them are. So if I just look at this list right now, let's take a look. If I said to you, I know this is small, but if I said to you, where is the abdominal region? You're not going to have any problem, right? Pointing to your abdominal region, right? Your abdomen. If I said point to your pubic region, let's not do that. But we know pubic. We know perhaps If I asked you to point to your femoral region, going to your thigh, you'd probably be okay with that. If I said, though, Simon says, point to your mental region. Go ahead. Simon says, point to your mental region. Ah, you guys are doing better than most, right? Mental region, I'm pointing to my head. That's where I would go, because I think that's where my mind is. But actually, the mental region is your chin. Okay? So some of these are not maybe on your top 10 list, and they're not familiar with you, or to you. This is also, as you look at page 7, a great place, because turn over to page 8 in Amerman book, and now you see that there is the same image with the same list of structures, but now you can practice labeling. So this is where those acetate pages come in. You can take one of these acetate pages, lay it right over, take a dry erase marker, practice, wipe clean, do again, wipe clean, do again. So rather than just having to do it once and, oh, now what do I do? You can practice over and over and over using these acetate pages. You're going to see all sorts of opportunities to lay these down and write with a dry erase marker many, many times. Okay, that's why we gave you a couple of them in the course pack. I want to see these nice and marked up. So this slide's really small, hard to see. You've got a bigger slide there. You'll find these terms also in your Martini book. You'll find them online all over the place. But let me take this opportunity right now to introduce you to some other things on the computer that you have access to. So I'm going to go out. I'm going to go all the way back to the beginning of Blackboard because I want all of you to see what you need to be able to look at. Sorry. So we're going all the way back out to my MCC, right? Everyone, if you're new to MCC or new to Blackboard, you go all the way out. My MCC, you'll be asked to log in. And you should now see, under your Blackboard courses, you should see Matoni, right? F01, F12, F58. That is your lecture section. And off from that, you have a mastering link. Now, I'm going to go to my lecture section right now because I can't get to Mr. Matoni's mastering site. We're working on that. But as you go in, you should see something similar. You should see all of his lecture materials that he has. And I have my lecture materials set up like this. All the lab things are here. And then there should be a mastering AMP link over here as well. Let me go to lab with you for a moment. And under lab, you're going to see folders for each lab. Right now you can see Lab 1 and Lab 2, and they'll be opening up sequentially as the semester goes on. There's also a set of website links that I'll be telling you about later on. So let's go to Lab 1, and here's where you see the full copy of the Amerman lab manual for those who didn't have their book yet, so you could do the assignment. And also below it are the instructions, the pre-lab instructions that hopefully most of you saw. I also give you an extra page to label if you want to practice labeling the microscope. And then finally here is the PowerPoint that I'm walking you through right now. So you can go in here and you can open this up on your computer or your tablet and you can come to this page and you can see it larger. You could, if you wanted to, print it out in full size, but you do have pages 7 and 8 with the same content. And some students would want to go to the library and just print this out full size as a study tool. That's your choice. Remember, you do have 300 pages of free copying that you've paid for in your technology fees as a student here. So take advantage of those 300 pages in the computer lab in the library. So I'm not going to go through all these with you, and you'll get to practice some of these things today. You know, if I said point to your gluteal region, we probably have that one down. If I asked you to point to your olecranon region or your olecranal region, many of you may not know that's the back of your elbow. The upper arm is the brachial region. The lower arm, your forearm, that's the antebrachial region. And the place where you normally give blood in the inside of your elbow is the antecubital region. So some of those are commonly used in the clinic, but are not necessarily very familiar to you. The crural region is the front of your leg. Okay, the carpal region, your wrist, your tarsals, or your ankle region. So look at this. Again, this will be an important part of your first lecture exam as well as your lab materials. Now, while I've got your attention and we're looking at the computer, I want to go to mastering. And if you haven't had a chance to do this, you'll click on mastering. It'll go through some registration steps with you. And this is what my lecture students are going to see. But it's very similar to what you're going to see with Mr. Matoni. It may be a different color. That's just a preference. But you're going to get a calendar. Okay, and my students have their first assignment due this week in mastering. But what I want to point out, not my individual assignments, but I want you to go over to the side, and it says study area. Okay, make a point of doing this. So definitely go over and go down to study area. And study area is now going to link you over to the website for the Martini textbook. And this has more information. There's so much good stuff on here. Every chapter in the textbook has its own quiz, its own pre-test, its own activities, its own practice tests. Here's where you have an e-text for the entire textbook. But where I want to point out right now is go down, and there is this thing called Flicks. And if you look right now at lab number 2, pre-lab number 2, if you look at it right now, go to your supplement and go down to your pre-lab number 2 page. It says at the bottom of that, it says turn in your Martini worksheet, page 7. Is that correct? Page 7. And just so you know, this little book of pages, right, this is the worksheet book. And next week, in addition to some of the pages from the Ingerman book that you're going to turn in with your pre-lab, you're going to pull out page 7 in here. It's perforated. And it's all about things we're talking about. It's going to help you. You're going to fill this out, and you're going to paperclip that as part of your lab, okay, next week. And right below that, it says, attach the completed AP Flicks mitosis quiz report. So over here, on the left-hand side, it says A&P Flicks. These are little movies. Great little produced movies. So click on the movies, and there's one on mitosis. Click on that. You'll watch this little video, and then there are 6 questions at the end about it. After you've done the quiz, click on Submit My Answers for Grading, and then print out that page. It's going to be a 1-page kind of summary of how you did on the quiz. And then attach that also to your pre-lab. So next week you'll have some Amerman pages, you'll have worksheet page number 7, and you'll have this 1-page printout after having watched this mitosis quiz. Okay? So it's all there for you. Look for emails from me to clarify this. I'm not looking for 100% on this. Okay? If you don't get 100, I'd like you to go back and do it again, but just know I'm looking that you've done it, right? That you've tried it and that you've at least read about and heard about mitosis a little bit. Under here, though, there are just so many beautiful things, study tools, and then we'll also be using this program called PAL 3.0, and this is a dissection tool as well as a model tool. So PAL is a rich resource that you're going to be using a lot this semester. So when you're in here, there's a human cadaver section, really cool to look at. We don't have cadavers here at MCC, so we won't be looking at this as much. But it also has a really rich set of models. So let's say we're doing the nervous system in a few weeks, and I want to look under the peripheral nervous system. Well, there's a picture of the brain and some central nervous system structures here as well. There's the spinal cord. These are the exact models we're using this semester. You can hover over things, and it will label them for you. You can click on Show Labels, and it will label things for you. There's also in here a really nice section on histology that we'll be dealing with throughout the semester, and a section on fetal pigs as well. So this is all linked through mastering, and you'll be hearing more about it, but I wanted you to go ahead and go into Blackboard, get registered for mastering, click around, see what's here, and now when you're doing pre-lab number 2, you're not like, what's that AP Flicks thing, mitosis? Now you know where to go, and you also know where to go now for that worksheet link. So just know there's a lot of really cool things we'll be doing online that you can do from the comfort of your home that will really help you be successful this semester. Any questions about that? Has everyone registered for mastering? Or who has registered for mastering? How's that? Okay, did you have any problems with the process? Okay, those who haven't done it, there's a code in your textbook that you got, and you'll just kind of go into Blackboard, go to mastering, and just follow a few instructions, get registered, and you'll be all set. It's very straightforward. If you have any trouble, let me know. Also, as you're registering for mastering, there's a little button that says Browser Check. And I really do encourage you to hit that. Your computer may not have the most up-to-date Java or Flash or some of these other add-ons, or may not have the most recent copy of Firefox or of IE. And in order for this program to work flawlessly, you need to have all the things that it tells you to have. If you're missing something, it will send you to a place to get a free download to get the most updated version. So check that browser check button out. It will very quickly tell you if your computer needs updating, and it's all free updates. So I just want to make sure you're not having any problems using the program when you're in the midst of it. Okay, so let's go on. We were talking about this slide and the fact that sometimes you'd want to go online perhaps and pull this up from Blackboard in a more complete size. So that's the outside of the body, right? That's what we can see and feel on the outside. Now let's go inside the body and describe some of the cavities where your organs are found. This image, this cartoon on the right, is turned to the side, and would you agree that the cranial cavity, that is this area where the brain is held, and the vertebral canal, this fluid-filled region where the spinal cord is found, that it's really more toward the back of the body, right? So the cranial cavity and the vertebral canal are part of the posterior or the dorsal body cavities. Whereas in the ventral side, what we have are the thoracic cavity in the bluish green and the abdominal pelvic cavity shown in red and pink. And those are the cavities, the hollow cavities, where the majority of our body organs are found. Now, our organs are separated from each other and are protected from each other and held in place by membranes. And there are three serous membranes. There are only three serous membranes. We're going to learn all three of them. And these serous membranes are actually a double-layer membrane. Now, in anatomy, membrane means layer. I mean, when you hear the word membrane, a cutaneous membrane, it's your skin layer. When you hear about a serous membrane, it's a layer. It's a layer of tissue that separates one thing from another. And these serous membranes are double layers. There is a parietal layer and a visceral layer. The term parietal by itself means wall. So circle that word parietal and then circle the word right below it, wall. Okay, so pariet means wall. Likewise, there is a visceral layer, and viscera refers to your internal organs. So what we have here then is a double layer. One layer is shrink-wrapped to the organ, the visceral layer. The parietal layer is shrink-wrapped to the cavity, the wall of the cavity. And in between, there's a thin space, fluid-filled, and that fluid is allowing your organs to slide over each other without building up friction. It allows your heart to beat constantly and not build up friction and heat. Okay, so these membranes are very important. So where are they? I've already said that. These membranes are found in the thoracic and the abdominal pelvic cavities. In this slide, we're looking straight on at the body. The blue represents the heart. The green represents the two lungs. The reddish pink represents all the gut organs. The term I want to point out on this slide is this term mediastinum. The mediastinum refers to the very medial, the middle area of the thoracic cavity. It looks like it's pointing to that yellow box, but it's not. This mediastinum is actually pointing to a bracket right there. So really the mediastinum is this box. It's this very protected area between the two lungs and very highly protected, right? You've got the sternum in the front, you've got the ribs on the side, you've got the vertebra, right, on the back. You've got two spongy lungs protecting this area as well. And what is found in the mediastinum are the most critical of your organs. So there you find your heart, the thymus, an organ found on top of your heart, the esophagus, the windpipe, the trachea, as well as the aorta and a number of other very important vessels are found right there in the mediastinum. The mediastinum is in the thoracic cavity. Right? It's part of that thoracic cavity, your thorax. So let's go through these three layers. These three membranes, I should say. So the first one is the pericardium. Peri means what? When you hear the word peri, the prefix peri. Around, right? So the pericardium is around the heart. And again, a double layer. The artist here has really overemphasized this double layering idea. The layer that is shrink wrapped to the heart itself would be the visceral pericardium. The parietal pericardium would be lining the sac that the heart is held within. In between, some fluid, allowing for the heart to beat and not build up heat and friction. Okay? So that's the pericardium. It is part of the thoracic cavity. You would say also that it's located within the mediastinum. Also in the thoracic cavity is a layer that's going around the lungs. And this layer also starts with the letter P, and this is the pleura. Okay, the pleura. Again, 2 layers. The outer layer, the layer that's lining the thoracic wall, would be the parietal pleura. The layer that's shrink-wrapped to the lung itself would be the visceral pleura. As I look at this model over here, I've got a lung in my hand. I can't see it. This is a very, very thin layer, but shrink-wrapped over the entire surface of this lung would be what? Visceral pleura. Also, very thin, but lining the inside of the thoracic cavity would be the parietal pleura. In between would be some space, some fluid-filled space, and it's also this space that allows for the lungs to expand. So this cartoon really overemphasizes that, but you got 2 layers, right? You got 2 layers here, and the expansion of the lungs is filling up some of that pleural space, the pleura, or the pleural space. The third serous membrane is also a letter P, right? The 3 Ps. And this is the peritoneum. And the peritoneum is going to be down in the abdominal pelvic cavity and is going to contain most of your digestive organs. So the peritoneum, peri, around, again. Now, we're not used to seeing this. This is the body on the right, sliced down. And toward the top, there's the liver. So I've got the liver on this picture. And I wouldn't ask you to label this. We're still getting used to something like this. But there's your liver. This sac is the stomach. What are all these other sections? What are all these other round things? Yeah, the intestines. We're not used to seeing them quite that way. But those are all sections of the intestine. And then there are some dark blue layers on here. Again, the entire, I'm drawing this all the way around the outside. This would be lining the abdominal pelvic cavity. So what layer is that? The outer line I just drew would be the parietal peritoneum. And then around all the stomach, the liver, around the intestines would be a layer called the visceral peritoneum. Okay. So know your 3 Ps, the 3 serous membranes. Any questions on that? Is that making sense? You'll get a chance to practice this a little bit this afternoon. If you go to the doctor and you say, hey, I'm not feeling very well, and they, where does it hurt? Well, it's kind of hurting in my lower right side. Okay. So they would say you have pain in your lower right quadrant. And that's okay. Okay, but it's not the most exact area. You could put a big plus mark across your abdominal pelvic cavity, put the umbilicus, the umbilical cord button right about the middle of that hash mark, and refer to this whole thing as 4 quadrants. Now notice that left and right are the left and right of the patient, the left and right of the model. And I know I'll see a lot of you kind of twisting and jiving the first few weeks as you're trying to figure out, okay, left and right. If you're looking at this image, I mean, this is my right side, right? So this is the right side of the patient. So this is right side, this is left side. So you'll get used to kind of flipping the left and right as you're referring to a patient. Even more completely, though, rather than drawing a big plus mark, draw a tic-tac-toe board across the abdominal pelvic cavity. And we'll divide this up into 9 imaginary areas. And let's learn these and go through these. So the first one is the umbilical region. So the belly button's kind of right in the middle of this whole thing. Right? So the umbilical region is right there in the center. Easy enough. Lateral to that, on either side of the umbilical region, are the right and left lumbar regions. Take your fingers right now, right? Go from your umbilicus, go around. Where do you end up? In the lumbar region, right? Your lower back region. And for me, I pass right by my love handles. So the L for love handles, right? Lumbar love handle. Okay, we'll pick up here with planes. So in the background, there is the coronal section. Now the coronal section is blue. Okay, so the coronal section in this, I know you don't have color on your PowerPoints, but that's the blue section. And if you slice someone with a coronal section, you're giving front and back portions. Anterior, posterior, ventral, dorsal sections. Okay? Coronal and frontal, same thing. So again, there's two words for this plane. Coronal or frontal, same thing. Use them interchangeably. The next plane is transverse or cross-section, also used interchangeably. This is the pink line. So this is going across her abdomen. Now it doesn't have to go across her abdomen. It could be cutting off her neck. It could be cutting off at the ankles. But regardless, when you cut the specimen, the heart, the liver, or the body, and you do so, and you get upper and lower sections, then you have cut with a transverse or cross-section plane. Later in the course, we'll be dissecting eyeballs. And it's going to say, cut the eyeball in a coronal section. So what do you have to imagine? They have the eyeballs in your body. Right? You're going to put the eyeball in the position that it would be in you, and then cut it in a coronal section. Right? So always imagine, if we're talking about the heart or the liver or a kidney, imagine it's in the body, in its correct position, and then follow the directions. Think about it from that perspective. The last plane is sagittal. And the sagittal plane in this image is the yellow one. It's going up and down, and it's creating left and right sections. Okay, so it's this yellow one right here. And the sagittal plane, again, left or right sections. It doesn't have to be right in the middle, though, does it? It could be over here, it could be over here, it could be anywhere else. All of these things have an infinite number of slices, and this is why we have wonderful things with MRIs and CT scans, because it can slice our body into thin sections and imagine or see tissues that way. One note about the sagittal section. If you are reading and it says that the section is a mid-sagittal, it's telling you something very special. There's only one mid-sagittal plane. It is the imagined perfect center, straight down the middle, giving you equal left and right sections. If it doesn't say mid-sagittal, don't assume that it's in the middle. If it says just sagittal, right, it could be in the middle, and they didn't say mid-sagittal, or it could be off to the side. And sometimes you'll see the term parasagittal, right, to describe all the other sections that are not perfectly in the middle. Occasionally, too, you'll hear about an oblique section. This is at a diagonal angle. So I've broken my ankle a couple of times, and every time I go back and they do an x-ray, they always look at my foot and my ankle straight on from the front and from the side, but then they'll also have the x-ray coming in at an angle to look at the arrangement of the ankle bones, at a different angle because they're being blocked when you look straight on from the front and the back. So an oblique section is more of a diagonal angle at some particular angle. That's going to finish up what I'm going to describe right now as far as these sections, and we'll come back to the microscope toward the end of our time.